welcome to today's Leetcode video. It's going to be a pretty long one because of just how long this question is, but let's just get into it. So we are given a string and representing an integer, and we want to return the closest integer, not including itself, which is the palindrome. And if there's a tie, we want to return the smaller one. So whichever one has the smallest difference, we want to return that. Okay, so it gives us some examples. Um, int is 123. The nearest palindrome is a valid palindrome 121, and then single digit numbers are palindromes. So like when we get one, there's 0 and 2 which are closer to it, but 0 is going to return the smallest one. So we want to find the smallest palindrome. So one possible way we can think about doing this is to generate a list of all possible palindromes, which is a brute force approach, and then get the answer that way. But one problem is that the size of the integer could be from 1 all the way to 10 to the 18th power. So that's going to be a lot of possible ints we don't want to compute. Um, Another way, a much easier way we can do this is to actually find the range of possible palindromes that are closest to our integer and then return the one which gives us the least amount of difference. Okay, so that's going to be a much better strategy and it's going to consume less space and save a lot of PC. Okay, so the first way we can go about doing this is to just instantialize an integer length, which is going to be the length of our string. And then we're going to have another integer I, which is going to be the amount of the string that we want to cut in half. Because we know a palindrome is going to be repeating itself when it gets to the end because the left and right pointers are always going to be the same. So we can just take the first half of the string, compute it to see if we can find the shortest palindrome within that first half, and then just return the whole palindrome by itself. So we just have to do less work. So if it's going to be, so we're going to have an integer I to calculate the amount of the palindrome that we want to cut in half. So integer I. And if it's going to be even, then we just want the length. We want the length of it minus 1. But if it's odd, then we just want to just cut it in half. Like that. Okay, so now we're going to use longs because we're dealing with such big amounts of data, so we want to be using long data types because the int could overflow possibly. So let's just make the long first half, and then we want to actually parse this long using a wrapper, and then just get the first half substring. The beginning index is 0, and then we want to go all the way to I plus 1. We want to parse this string. And then after that, now that we have that done, we can just go ahead and just like instantiate the list of possible palindromes this could be. So this is going to be 5 possible palindrome values. And I'll explain later why it's going to be exactly 5 palindrome values that we're dealing with. But first of all, we just want to instantiate a list of type long. Long right there. And then just different possibilities. And then it's going to be an array list. Okay, so one of the first possible values. So imagine that we had the given number was like they give us 8,000 or something like that. Well, we know that the number 9, just the number 99999, is still a valid palindrome, and this can be used to actually solve a possible edge case. So let's say like the value is just like it's near the initial like 1000 stage. So like it's like here or it's like 99998. Um, this will be like a buffer zone to like get the shortest values when it reaches a new digit to place. So we want to that could be a possibility. So we can say possibilities to be our first possibility where we're going to make a helper function called half to palindrome later in the video, which cuts the palindrome in half and gets the smallest version that we need. So just call this first half minus one. And then in this half palindrome helper function, we also want to return a Boolean value to see if it's going to be even. So we can parse this much easier. So in inside the arguments, we just want to like do the calculations in there by itself. And then there's going to be another edge case here. So like let's imagine um, we're dealing with numbers that are greater than 1,000, which are much closer to 1,000 than it is to like 9999999. So then another valid palindrome would be this. This would deal with the numbers that are above 1,000, but they are closer to 1,000 than it is to 99999. So that could also be another possible case. So how we can do that is we can add another possibility. So possibilities.add our helper function that we haven't implemented yet, and then first half plus one instead. And we also want to turn it in that Boolean condition to see if it is even or not. And then the oh, we also want to calculate it at its original position. So possibilities add half to palindrome, where we don't even edit it at all. And then other possibilities include half to half palindrome, but instead we want to not use this helper function anymore. We want to use the math function and then add the power value to it. So like, what if it's like this, or it's like this, and we start reaching these bigger values where the palindrome could be reaching higher values? Then we want to consider using the math.power value to help us calculate the smallest difference for numbers that are bigger than 1,001 or like 99999. So for that, we'll be using the long data type because these numbers could reach to literally the thousandths, 10 to the 18. That's a big number. So math.pow instead to 10, which is a base number for powers, and then length minus 1. So when the length reaches negative 1, and then you want to add minus 1 to that. That will handle the lower end of things. And then another one, supposed to add long math.pow 10 length plus 1. Okay, now these are the 5 possible possibilities that our palindrome could return. And now we want to get to the logic of the helper function first before we actually can compute the final answer. Right? So for our helper function, it's going to be a very simple name. It's going to be private. The visibility will be private because you only want this function to access it. This is a Leetcode question, so I'm not really going to be going much into that, but have to palindrome, which is the function that we're calling up here in our values. And we want to have in 1 value called left, which will be the left half of the number that's going to be inputted in the string. And then you want to add a Boolean value, even, which we already compute in each of our parameters. So after we've done that, let's create our result integer, which is going to be a long, actually, not an integer, called a left. And we want to make sure that we're working with even numbers as much as possible. So if we're working with an odd number, we want to actually convert this into its like even equivalent so it can be easier to work with. So if it's not even, so it's an odd, then we want to make sure that this left value we divide it by 10. And while left is a non-negative number, so it's greater than 0, while left is greater than 0, then we want to append the numbers that are going into our integer array. So for our first half, it's going to be res times 10, so we can get to that next decimal place, to that next place, and then left modulus 10, which will get the remainders and then just like append it to that value. Then after that, we want to shift our left input to the left one time. So we can do this in a long expression by just dividing it by 10. After that, we want to just return the rest so we can bring it back into our nearest palindromic sequence so we can start calculating the smallest difference. Now, the logic for calculating the smallest difference is pretty simple. Um, we just want to see um, we want to see if we can find the smallest difference in our input. So we can go about doing this is to just instantiate another long called the difference. And for now, we're just going to give it a placeholder value of like just the maximum value we could possibly have in Java. And then the result is 0. And then this NL, which is going to be our kind of our input string, but parsed instead, it's going to be long dot parse long, and this is our input parsed. Okay. Now, for the possible candidates in our possibilities. So we have an array list of possibilities and we want to iterate through that. If one candidate, if we have a candidate that's literally just equal to our parsed string, which means that our parsed string is literally one of the candidates, so the difference has to be 0. So this is possibly the smallest we can ever get. We'll just press continue. The reason why we're not returning this value is because we there's still other possibilities, but for now, this is the best case possibility that we can have for the input is that if it's just equal to the responsibilities. So that means we don't even have to go through the other conditional, we can just return the value of our string with the result as a parameter because that's the smallest value. If not, there's still some more logic we have to do. So we have to get the absolute value difference of the candidate that we have or that we're currently iterating through minus our parsed in, which should give us the absolute difference of that. And after we found that, we want to check if it's less than the difference that we currently have. And our difference right now is like an infinitely long maximum value. So yeah, it's definitely going to be bigger than that. But the thing is that we're going to be iterating through this the whole time. So this is subject to change. It can get smaller very fast over subsequent iterations. So if it is smaller than our difference, then we want to update said difference using the math absolute value, which is basically what we did over here, the candidate that we're on minus the current minus our current difference. No, minus our parse integer, our parse long, and then set the result equal to that candidate. That is current. This is the current smallest difference that we have. If that's not the case, then the other possible case is that if it's directly equal to the candidate, so if the absolute value difference is equal to our difference. So what can we conclude about this? We can conclude that since the difference between our candidate and our difference is set equal to difference, we could just set our result equal to the minimum result. So we can just go ahead and the result math.min res and then candidate. Let's just check the code to see if it could work. Oh, I think I see what's wrong here. I put this in the wrong kind of like sub branch. So this should be instead underneath this semicolon right here. Now let's see if that runs correctly as expected. What the heck is wrong with my flow? Okay, so we can see that the code runs as expected. The time complexity is O of n, and our space complexity is O of n as well. So it's for dealing with linear possibilities, 5 possibilities for every set integer placement. Yeah, thank you guys for watching. This was a Leetcode hard, so hopefully I tried my best explaining it. If I did not, please let me know in the comments on how I can improve, and I'll see you guys in the next